All right, welcome back, students. Good news. I will be getting an external microphone to hopefully deal with the sound in these recordings. I've heard the sound and it is terrible. So, all right, today we are going to be doing geometry 1.2b. And today we are going to be graphing piecewise functions. So yesterday we plugged in numbers and found out where they were. Today we're going to be graphing piecewise functions. So first piece, let's do a refresher of the domain. The domain of a function are all possible x values. All possible x values. So the domain you can think of as how wide is our function. All possible x values. The range is all possible y values. So you can think of how tall it is. So what's the lowest and what's the highest y value. So that's our domain and range. All right. So what we're going to do is I'm going to give you a piecewise function. Let's take f of x equals 2 if x is less than or equal to 1, or x minus 3 if x is greater than 1. Okay. So we didn't have room in our student journal, unfortunately, so I'm going to encourage you to find a notebook, and if you need one from me, I can give you a graphing notebook and you can use it this whole semester. We shouldn't be using it too much, so I'm going to use this and then rip it out and staple it into my student journal so I have the notes with me. So here we are. We are going to graph this piecewise function. Graph this piecewise function. So the very first thing I'm going to do is I'm going to make a borderline. I'm going to make a borderline which is going to help me to graph this. So I'm going to make my x and my y axis right there, and I'm going to create a borderline. And what I use for my borderline is this. So I see that x is less than or equal to 1, and x is greater than 1. So these are actually this is my borderline right here, and it's 1 and it's 1. So I go to 1 right here, and what I'm going to do is I'm going to create a borderline, and I'm using a highlighter because it's not it's not part of my function. It just shows me where pieces begin and end, where they begin and end. So now what I'm going to do is I'm going to draw each of my individual functions. So right here, f of x equals 2. F of x equals 2. You know that f of x is synonymous with y, right? So we could rewrite this as y equals 2. Well, y equals 2, that's a horizontal line, right? For every x value, it doesn't matter what my x value is, my y equals 2. So y equals 2 every time, no matter what. I could put 1,000, my y equals 2. I could put 0, I could put 1, I could put negative 2. So no matter what, my y equals 2. So 1, 2, there's my y. And then I have this line. And now I'm drawing it in pencil because of my borderline. I have my restrictions right here. So f of x equals 2 if x is less than or equal to 1. So less than or equal to 1, so it would be everything on this side. So I'm going to go ahead and erase this whole side of my line. And it's right here. Now it's less than or equal to, so what do I do with my circle? If it's equal to, I fill that circle in. So this right here, that's my first piece of my piecewise function. Now I'm going to take this second one, f of x equals x minus 3. And if you remember, if I want to draw this line, my slope, this is written in y equals mx plus b. This is review. If you don't get it, I'm going to put a link to a Khan Academy video re-explaining this, but we have our y equals mx plus b right here. Y equals mx plus b. So my slope, or my m value, is 1. It's 1. And if I'm doing slope, I'm going to write it in a fraction, 1 over 1. And then my b is my y-intercept. My y-intercept is negative 3. So my y-intercept tells me where I start. So negative 1, negative 2, negative 3. So I start right here with my line, and my slope is up 1 over 1, up 1 over 1, up 1 over 1. So that's my slope. So this right here is my line. Now, I have to look at my borders for this equation. X is greater than 1. So here's my borderline right here, and it's greater than 1. So I have to erase all of this, erase all this, and actually at 1, it's greater than, it's not equal to, so this has to be an open circle. So there's my piecewise function right there. This is a graph of this. It's a graph of this piecewise function. Now you notice, for a function to be a function, I cannot have 2 y values for 1 x value. So you notice the 1 is a part of this line, but it is not a part of this line. So yes, this remains a function. Now with this piecewise function, what is my domain and my range? So my domain is how wide it is. So what are my x values? Well, negative, my x value goes on forever. And then this line actually extends on forever. So my x values go all the way negative, all the way positive. So my x values are all real numbers. And Mr. Davies likes to do this. I'll see if this is going to bite me in the end, but if you could do it well. Mr. Davies likes all real numbers is a cursive R. So that is representative of all real numbers. So if you put the cursive R like that, I'll know you mean all real numbers. All right, now, what is my range? And my range is how tall it is, how far it goes up, and how far it goes down. So it does not extend below this negative 2. So my range for my y values is nothing below negative 2, and it's everything above negative 2, but not including negative 2. So my y is greater than negative 2. It's my domain and range for this piecewise function. Alright, let's do one more, and this next one we will do this next one with, we'll piecewise 3 different ones together. So, what if we have f of x, and then we have equals 4 if negative 5 is less than or equal to x, which is less than negative 2. What if we have f of x equals x squared if negative 2 is less than or equal to x, which is less than 2. And what if we had f of x equals x plus 2 if x is greater than 2. Alright, now if you remember, first step is to do your border lines. And my border lines for this one are going to be negative 5, negative 2, negative 2 again, 2, and 2. So my border lines are going to be at negative 5, negative 2, and 2. Let's go ahead and let's draw this. Trying to think of how I can leave most room to do the work. Alright, so border lines, negative 5. 1, 2, 3, 4, 5. Border lines, negative 2, 1, 2, and 2, 1, 2. So those are my border lines. I missed my calling. I should have been a sound effects person. Do you hear those sound effects for those lines? That was great. Okay, so let's do our first one. Let's do y equals 4, or f of x equals 4. And so what I get is no matter what I put in for x, my y is 4. So you put 0, negative 2, 1, 2. No matter what I put in, my y is equal to 4. So 1, 2, 3, 4. And I have that line. Boy, that is, geez, that is a terrible line. That line right there. Okay, and now I look at my parameters. I go to my borders, and I see x is greater than or equal to negative 5. So I go to negative 5, and greater than or equal, so it's going to be colored in. So nothing below here. So make sure you're doing this in pencil, because you have to erase. And x is less than negative 2. Negative 2, so that's it, right there. So this right here is an open circle at negative 2. So that's it for our first piece of this function. Now let's take this next one. F of x equals x squared. So I have f of x or y equals x squared. Well, shoot, I forget what that is. So I'm going to, I know it's a parabola, but I forget exactly where it is. So I'm going to go ahead and do negative 2, negative 1, 0, 1, 2. So if I plug a negative 2 in here, I get negative 2 squared. Negative 2 times negative 2 is 4. If I plug in a negative 1 squared, I get negative 1 times negative 1, that's 1. 0 squared is 0, 1 squared is 1, 2 squared is 4, and just for a heck, I'm going to go 3 squared is 9. Oh, that's right. Now I remember. So I have 0, 0, negative 1, 1, positive 1, 1, negative 2, 4, positive 2, 4, and then 3, 9. But look, x is greater than or equal to negative 2, so it's bigger than this. And then it's less than 2. So my parameters are right here. So I'm going to stop there. This 3 is not included in this equation. So if I were to draw it, it would look like this. But anything outside of negative 2 and 2 is not included. We'll take that out. Now, x is greater than or equal to negative 2. Oh, so my parabola, which hits right here, so I fill that in for this parabola. And don't forget, it was an open circle for this line, closed circle for this line, so I still have a function because this is only part of this function. And then this goes up, and it is less than 2, so this is an open circle. So you see, if I take this step by step, it becomes doable. If I were to look at this and just try and graph it, no way. But if I take it step by step, I can actually do it. So let's look at this one. So f of x equals x plus 2. So f of x or y equals x plus 2. Now I can do two things. One is I know that my slope is 1 over 1, and my y-intercept is 2. So I could just go to 2, and I can start graphing it. If you forget that y equals mx plus b, if you forget how to do this, you can just as easily make a XY chart. I like -2, -1, 0, 1, 2. It just gives me a good overview. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So I could graph those. So, let's graph it this way first, then I'll show you how these line up right on top of it. Y-intercept is 2, 1, 2, and then 1, 1. Up 1 over 1, up 1 over 1, up 1 over 1. So there's my line right there. So I can draw this line in. Like that. Now if I were to look at this and say -2, 0, -2, 0, sure enough, there it is. -1, 1, 0, 2, 1, 3. See how either one of these gets me the same line. So now that I have my line, I'm going to have to come up here and look at my borders. X is greater than 2. Okay, here's 2, so X is greater than. So I actually erase all of this. So X is greater than 2. So, and it does not include 2. There's my X is greater than 2. So I just graphed my function. There's my function. And the last piece I'm going to do is my domain and my range. My domain. How wide is this? What are my X values involved in this? Well, my X values don't extend this way. So my lowest X value is a -5. And then, so I have -5. Keep that in my head. And then this way, in the positive direction, it extends forever. So X is greater than or equal to, because it's shaded in, greater than or equal to -5. -5. And then my range is all of my Y values. So Y, I have nothing below 0, and then upwards it goes on forever, so Y is greater than or equal to, because it includes that, 0. So that's my domain and range. Alright, make sure you have those two problems in your notes. So I need to see that for your homework, and then for part of your homework. And then on page 10 and 11, you're going to do 10 through 13. 10 through 13. So let's look at these. I'll do one of them for you, and then you do the rest. No, why don't I do number 11. Okay. So we're going to put up our borders. I have a border at 2 and 2. Well, that makes the border easy. It's at 2 and 2. Okay. Oh, that's why it's upside down. Alright, so my border's at 2. So I go 1, 2, and I make my border right there. And now for my first one, I have Y equals 4 minus X. So what I could change this to is Y equals -X plus 4. So I have a slope of -1 over 1, the Y-intercept of 4. So, and you can also do an XY if you would prefer. So I have 4, 1, 2, 3, 4, and then I have a down 1 over 1, down 1 over 1, down 1 over 1. So there's my line, down 1 over 1. So that's my line. Now, X is less than 2. So it's less than 2, so I have to take this part out. And this is an open circle. That's an open circle. And if I were to plug some numbers in here, I could go 0. So 4 minus 0 is 4. I could go 1, -1, and 2. So 4 minus 1 is 3. Negative 1, so it would be 4 minus a negative 1, so 4 plus 1 is 5. 4 minus 2 is 2. So I have 2, 2. I have negative 1, 5. So you could plot your line that way if you prefer. And then we'll check out this one. Y equals x plus 3. So for this one, I have a slope of 1 over 1. I have a y-intercept of 3. So I go 1, 2, 3. I got 1, 1, 1, 1. Don't forget, if you go positive 1, you could also go negative 1, because a negative over negative equals a positive. All right, and then this one is x is greater than or equal to 2. So it's all of this right here. So I'm going to take this out. Greater than or equal to. So this is going to be a solidified circle. There it is. So there's my piecewise function. I have an open circle on this line, a closed circle on this line. So my domain is, let's see, this goes on forever this way, this goes on forever this way, so my domain is all real numbers. And my range, I'll just put all real so that you know what that is, all real numbers. My range is nothing lower than the 2, but it doesn't include the 2. So y is greater than 2. Okay. Go ahead and do 10, 12, and 13. And best of luck. If you have any questions, give me a call. There goes our first one. If you wanted to look on Desmos, I entered our first one in there. If you have any questions, give me a call. And hope you do well.